Grounding is critical in any electrical system to ensure safety. All bare ground wires, also known as equipment grounding conductors, must be connected to a separate grounding lug or a ground bar within the service panel. This grounding lug or bar must be securely fastened directly to the metal enclosure of the service panel. This connection provides a low impedance path for fault current to return to the source, allowing overcurrent protective devices like circuit breakers to trip and clear the fault. Proper grounding minimizes the risk of electrical shock and equipment damage. The National Electrical Code, also known as NEC, provides specific requirements for grounding and bonding. The NEC Article 250 covers grounding and bonding. A grounding electrode system is used to connect the service panel to the earth, providing a reference point for voltage. This system typically consists of a ground rod, a metal water pipe, or a concrete encased electrode. The grounding electrode conductor connects the grounding electrode system to the grounding bus in the service panel. Bonding refers to the interconnection of all metallic parts within the electrical system to create a continuous electrical path. This includes metal conduits, metal enclosures, and equipment grounding conductors. Bonding ensures that all metallic parts are at the same electrical potential, reducing the risk of electrical shock. The size of the grounding and bonding conductors is determined by the size of the service entrance conductors, as specified in NEC Table 250.66. Now, let's discuss the arrangement of wires within the service panel. It is generally recommended to have the bare ground wires on one side of the panel and the neutral, which are white wires, on the opposite side. This arrangement helps to keep the wiring organized and makes it easier to troubleshoot problems. The neutral wires should be connected to the neutral bus bar, which is also isolated from the service panel enclosure. The neutral bus bar is typically located on one side of the panel, while the grounding bus bar is located on the other side. Circuit breakers are installed to protect individual circuits in the home. They should be installed on the load side of the service panel, connecting to the hot wires that supply power to the circuits. Circuit breakers are sized according to the ampacity of the circuit conductors and the load they serve. When working with a service panel, it is essential to follow all safety precautions. Always turn off the main breaker before working on the panel to de-energize the circuits. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the work. The image of a completed 200 amp service panel provides a visual reference for proper wiring and component placement. The grounding lug is located on the bottom right side of the panel, securely fastened to the enclosure. All bare ground wires are connected to the grounding lug, ensuring a solid ground connection. All neutral, white wires are connected to the neutral bus on the left side of the panel, keeping them separate from the ground wires. The circuit breakers are installed on the right side of the panel, protecting the circuits in the home from overcurrents. The specific arrangement of wires and equipment in a service panel may vary slightly depending on the specific panel and electrical system. Always refer to the manufacturer's instructions for specific installation requirements. The panel's main breaker disconnects all power to the circuits. Branch circuit breakers protect individual circuits. A ground fault circuit interrupter, also known as GFCI, breakers provide additional protection against electrical shock. An arc fault circuit interrupter, also known as FSI, breakers protect against electrical fires caused by arcing faults. Wire connectors are used to make secure connections between wires. Cable clamps secure cables entering the panel. Conduit provides protection for wires running outside the panel. The panel should be properly labeled to indicate the circuits that each breaker controls. Regular inspection and maintenance of the service panel are essential to ensure its safe and reliable operation. Check for loose connections, corrosion, and damaged components. If you notice any problems, have them repaired by a qualified electrician. Remember that working with electricity can be dangerous, so always follow safety precautions and consult with a qualified electrician if you have any questions or concerns. Here's a further breakdown of key components and concepts. Let's begin with the grounding electrode system. This system is the foundation of electrical safety, providing a path for fault current to the earth. It consists of one or more grounding electrodes, which are typically ground rods, metal water pipes, or concrete encased electrodes, also known as UFRs. The grounding electrode conductor connects the grounding electrode system to the grounding bus in the service panel. The size of the grounding electrode conductor is determined by the size of the service entrance conductors, as specified in NEC Table 250.66. Bonding is the process of connecting all metallic parts within the electrical system to create a continuous electrical path. This includes metal conduits, metal enclosures, equipment grounding conductors, and metal water pipes. Bonding ensures that all metallic parts are at the same electrical potential, reducing the risk of electrical shock. The bonding jumpers are used to connect different metallic parts together. The size of the bonding jumpers is determined by the size of the circuit conductors, as specified in NEC Table 250.102. Equipment grounding conductors, also known as EGC, are used to ground non-current carrying metal parts of equipment, such as appliances, tools, and lighting fixtures. The EGC provide a path for fault current to return to the source, allowing overcurrent protective devices to trip and clear the fault. The EGC can be bare, green, or green with a yellow stripe. The size of the EGC is determined by the size of the circuit conductors, as specified in NEC Table 250.122. Neutral conductors carry the return current from the load back to the source. The neutral conductor is typically white or grey. The neutral conductor is connected to the neutral bus in the service panel. The neutral bus is isolated from the service panel enclosure. Hot conductors carry the current from the source to the load. Hot conductors can be black, red, blue, or any other color except white, gray, or green. The hot conductors are connected to the circuit breakers in the service panel. Circuit breakers are overcurrent protective devices that are designed to trip and interrupt the flow of current when an overcurrent condition occurs. Circuit breakers protect the circuit conductors and equipment from damage caused by overcurrents. Circuit breakers are rated in amps, which indicates the amount of current that the breaker can carry before tripping. Ground fault circuit interrupters, also known as GFCIs, are devices that are designed to protect people from electrical shock. GFCIs monitor the current flowing in the hot and neutral conductors of a circuit. If there is a difference in current between the hot and neutral conductors, it indicates that current is leaking to ground, which could be through a person's body. The GFCI will trip and interrupt the flow of current in a fraction of a second, preventing a dangerous electrical shock. Arc fault circuit interrupters, also known as SIs, are devices that are designed to protect against electrical fires caused by arcing faults. Arcing faults occur when electricity jumps between two conductors, creating a high-temperature arc that can ignite nearby materials. SIs monitor the current flowing in a circuit for the characteristics of an arc fault. If an arc fault is detected, the SI will trip and interrupt the flow of current, preventing a fire. Surge protective devices, also known as SPD, are devices that are designed to protect electrical equipment from voltage surges. Voltage surges are temporary increases in voltage that can damage sensitive electronic equipment. SPD divert the surge current away from the equipment and to ground. SPD are typically installed at the service entrance in the branch circuits. The service panel enclosure is the metal box that houses the circuit breakers, wiring, and other components of the service panel. The service panel enclosure provides protection from physical damage and electrical shock. The service panel enclosure must be properly grounded to ensure safety. Wiring methods refer to the types of cables and conduits that are used to run electrical wires. Common wiring methods include non-metallic sheath cable, also known as Romex, metallic conduit, and electrical metallic tubing, also known as EMT. Each wiring method has its own advantages and disadvantages. The choice of wiring method depends on the specific application and the requirements of the NEC. Electrical boxes are used to enclose and protect electrical connections. Electrical boxes can be made of metal or plastic. Electrical boxes are required at all wiring terminations such as switches, receptacles, and lighting fixtures. Wire connectors are used to make secure connections between wires. Wire connectors can be screw-on connectors, push-in connectors, or crimp-on connectors. The choice of wire connector depends on the size and type of wire being connected. Cable clamps are used to secure cables to electrical boxes and service panels. Cable clamps prevent the cables from being pulled out of the box or panel, which could damage the wires and create a safety hazard. Conduit fittings are used to connect conduit to electrical boxes and service panels. Conduit fittings provide a secure and watertight connection. Labels are used to identify the circuits and components in the service panel. Labels help to prevent confusion and make it easier to troubleshoot problems. A circuit directory is a list of all the circuits in the service panel, along with their corresponding breaker numbers and the areas or equipment that they serve. The circuit directory is typically located on the inside of the service panel door. Regular inspection and maintenance of the service panel are essential to ensure its safe and reliable operation. Check for loose connections, corrosion, and damaged components. If you notice any problems, have them repaired by a qualified electrician. Remember that working with electricity can be dangerous, so always follow safety precautions and consult with a qualified electrician if you have any questions or concerns.